Hello friends, welcome my channels. Today's discussion June 2011 CSIR NET. The degree of extension cube root 2 and cube root of 2 over the field q root 2 is a and b. A is equal to 1, b is equal to 2 and 3. We have to find out degree of extensions. So friends, we know that before the solutions you have to know the theorem. Answer theorem. Let F subset of E and E subset of K be fields if K degree of extension K over the field Q over the field E less than infinity and degree of extension E such that if less than infinity, then number 1 degree of extension K over the field F less than infinity, and number 2 the degree of K such that F equals to degree of extension K such that E into E such that F. So friends, I apply this formula. Now here you see that Q into root 2 and cube root 2 to the power half, and this is the and another factor is the Q. So friends, we see that this is the here we see that comparing this and comparing this also, if in here K is the E, after that F. So friends, we consider comparing this with this and this with this with this and this with this, and this is the total. So friends, degree of Q root 2 over Q is equal to degree of x square minus 1 into degree of x cube minus 1 is equal to 6, and q root 2 such that q equals to degree of x square minus 1 is equal to 2. So friends, whatever we get, we know that q root 2 comma cube root 2 such that q root 2 equals to q root 2 comma cube root 2 such that q divided by q root 2 such that q is equal to 6 divided by 2 is equal to 3. This is my answer. So friends, now let's start the normal extension. Let's try to discuss. So friends, normal extensions, in extension E of a field F is called normal if every irreducible polynomial polynomial in fx that has a root in E splits into function in E. So an extension E of a field f is called normal if every irreducible polynomial in fx that has a root in E splits into function in E. So friends, let's try to give one example. Example CR, and another example is number 2 RQ. So friends, this is the meaning of that fx for all, this is the meaning is that for all fx belongs to capital Fx belongs to f such that if fx is linear factorizations, means x minus alpha 1 x minus alpha n is linear factorizations over E, splits in E. So friends, let's start to discuss that. I want to clear this concept. E and fx is splits into E. So friends, let's try to discuss C and R. Number 1, this is the example I will discuss. Example number 1, CR. fx belongs to Rx. fx is irreducible. Fx is irreducible, and x square plus 1 belongs to Rx, and x square plus 1 splits into x plus I into x minus I, where I comma minus I belongs to C. So CR is a normal extension. Number 2, RQ, where R, this is the R and this is Q. So friends, let fx equals to x cube minus 2 belongs to qx, and according to the Eisenstein theorem, this is x square plus 1 is irreducible. This is irreducible, and according to the ATQ Eisenstein theorem, Eisenstein criteria p is equal to 2, and where 1 does not divisible by 2 and 2 does not divisible by 2. So friends, according to the Eisenstein criteria, this fx is irreducible over Q. So Eisenstein criteria, fx is irreducible over Q, because we know that a0 plus a1x plus up to an x to the power n, and p does not divisible by an, and p does not divisible by an minus 1, but p divisible by a0 and p divisible by a n square. This is the Eisenstein criteria, irreducible over Q, a n square. So friends, this is the leading coefficient a n. Leading coefficient is does not divisible by p. So you see that leading coefficient is does not divisible by 2. So irreducible, x cube minus 2 is irreducible, and here we see that when we will split that x minus 2 to the power 1/3 and x cube minus 2 is equal to x 1/3 and x minus 2 to the power 1/3 omega and x minus 2 to the power 1/3 omega square. This is the formula. So friends, whatever we see this portion is complex. This portion is complex, and 2 to the power 1/3 belongs to capital R. So friends, we see that whatever we see that x cube r cube is not normal extension. Thanks for watching.